A lot of waxes, when they're hot, have a certain density. They're bigger when they cool, like the traffic and flip flop. By adding a filler, we reduce that shrinkage. And the reason we do that is that we have a wax that we can pour into a temporary mold. Maybe we made a mold out of alginate. And we pour wax in there, we get a new master, we clean up, fix any imperfections, and now we have a wax mask that we can make a production mold from. So that's the main use for the PolyWax 15, is to make a part to be reproduced later on. It is not designed for foundry applications, because when you melt out the wax, you leave behind some of that filler, which produces an ash in the mold. So it's not a foundry wax. It's designed as a interim master material. We manufacture 3 different latex materials. We have our PolyTek 60, which is a traditional brushable one-component latex mold. Latex, the only industry latex is used anymore is ornamental statuary, and even that is starting to fade rapidly. This mold, they're all brush-on molds. This mold probably has close to 30 coats on it. Maybe you get 2 coats a day. Like 2 weeks to make a mold. That's a long time. The guys who use latex successfully might have 200 masters set up in a room like this. And they rub on this file and they go around and brush around. So all day long, all they're doing is brushing rubber on all these masters. At the end of 2 weeks, they've got 200 molds made, which isn't bad. But latex is about 30% water. So when the water and ammonia evaporate out, you get about 10% shrinkage. So it's okay if you're making a garden gnome or a bird bath and you get 10% shrinkage, no big deal. But if you're making a patio paver, or you're making a not technically 50-foot spot, you can't have 10% shrinkage because nothing's going to fix it. It'll be all over the place. So latex, the other thing about latex is, I'll say 10 years ago, latex was half the cost of urethane. Today, latex is more expensive than urethane, because no one's using it anymore, so we're not importing as much anymore, and the cost has gone through the roof. There have been several companies that make latex only. They're out of business now, because 15 years ago, latex was super strong, and the urethane rubbers were not anywhere near as good as far as stretch and tear. Our chemistry has gotten much, much better over the years, and now our best urethane rival the stretch and the elongation of latex. Mother Nature's still pretty good. Latex still has an edge, but I can make a urethane mold in an afternoon. I don't wait 2 weeks. I put that mold in production the next day. So the labor cost in going from latex to urethane saves tremendous amounts of money. Latex N is a liquid latex that is designed for spraying or dipping applications. And then we have latex phosphate. Latex phosphate has a filler in it. And it basically has a plaster mold. You fill that mold with latex phosphate, and you dump out the excess, kind of like the casting so it slips. So what's left behind is a very thin layer of latex, and when it dries, produces a Halloween mask type casting. This mold was made in 96. Casting was made in 96. As you can see now, it's all cracked. It's just like any of the latex that an old rubber band you find in your drawer. It deteriorates over time. So latex would not be a permanent material. In this area, we've got these are products that we don't manufacture. These are a Forton product. Ball Consulting, if you're interested in these materials, we'll get you information. But Ball Consulting manufactures a polymer that replaces water in plaster and concrete casting. And it produces a harder, more durable plaster casting. They use FTR 95 and the polymer. They've also got polymers for GFRC, which is glass fiber reinforced cement. So a lot of architectural companies, restorations now, to replace old, failing terracotta facades are being done with GFRC. So instead of having to cast a solid concrete part, you can keep the concrete casting 3/4 of an inch to an inch thick. That'll be about the same weight as the terracotta. Be much more durable. You can color match it. So this is really what's being done as far as architectural restoration.
What's that? You mix with resin, or by itself you can...
It's a cement. It can be as simple as you don't need to add the polymer. You can just add cement
sand and these fibers. You can look in the back here and you can see that there are fibers. And this is not fiberglass that you'd use with polyester resin. It's a special fiber that is alkali resistant, so it won't deteriorate when it's mixed in with the concrete. So by adding a polymer, you can make it even stronger and keep it even thinner. So GFRC, glass fiber reinforced cement, GRG, glass fiber reinforced gypsum. So for interior applications, they're using GRG because plaster does fine indoors. Plaster products don't do very well outdoors, and that's why you use cement. So anyway, we don't. You can see these are all examples of Forton products, both concrete and plaster. If you have questions, you can let us know. The other wax that we manufacture is our skin wax. Skin wax is a low temperature melting paraffin. Basically, you dip your hand in it, dip your hand in cool water, back in the wax, back in the cool water, back in the wax, about 3 times, and that will produce a mold of your hand or foot or whatever else you dip into the wax. It's not good for your face because you don't want to dip your face into a molten bath of wax. But for hands and feet, it gets excellent detail. You can actually get rubber hair. With the wax, you want to make sure that you apply a little baby oil to the hair on your arm. Otherwise, when you're done, there will be no more hair on your arm. And it can be a painful process to remove that wax. So very, just we'll show you how to do that. But and today, the next 2 days, everybody's going to get a chance to make hands. Normally, you can take your hand out, use that mold, peel off the wax, put the wax back in. But we prefer not to put everybody use wax back into the bath. As it gets a little low, we have some melt and we'll just dump some more in. What's that? Yeah, so we get a wax mold now, and into that wax mold you can cast mostly. You're casting rubbers because the rubbers don't generate much exotherm, much heat during the chemical reaction, so it doesn't get hot enough to melt the wax. You can do bonded bronze, you can cast liquid plastic in that wax mold, but you've got to submerge that wax mold into some cool water so that the wax stays solid while the resin cures. Otherwise what happens is the resin heats up, melts the wax, and you end up with a big blob sort of mess.